Welcome to a virtual tour of our office. We are located in Chanhassen, Minnesota, or about 16 miles southwest of Minneapolis. We hope you enjoy learning a bit about what we do. One thing many notice upon their arrival is the large soccer ball-looking radar dome behind our office. It scans the skies 24 hours a day, 7 days a week. We can use several scan types called volume coverage patterns, or VCPs, for different weather situations. Two of the most common types are VCPs 31 or 32, which are used for very light precipitation or general weather watch, and VCPs 12 or 212, which are much quicker, more comprehensive scans during stormy events. Notice as distance increases from the radar beam increases in altitude. This is because of the curvature of the Earth and underscores the need for severe weather spotters. Another thing many people notice is our upper air shelter building, where we prepare and launch our weather balloons twice per day. Hundreds of locations around the world launch the balloons at the same time, 11Z and 23Z, or 6 a.m. and 6 p.m. local time, to help global forecast models, which are run a few hours later. This is a balloon ready for launch. Attached to it is an orange parachute, followed by 80 feet of string, and the instrument used to measure the atmosphere called a radiosonde. The 80 feet of string allows the balloon not to alter the atmosphere the instrument is trying to measure. These are harmless weather instruments, and if found, we encourage people to return them in the packaging attached so we can reuse them. Here is a real launch that took place in 2016. The balloon will reach an altitude of about 100,000 feet, or 19 miles high, and expand to a diameter of 20 feet before popping. It takes about 2 hours to complete a flight. As the instrument rises, it takes continuous measurements of temperature, relative humidity, and pressure and sends them to our office. The instrument also sends its GPS coordinates, so our equipment can calculate instantaneous wind speed and direction. When you first walk into our operations area, you will see clusters of workstations. During severe weather situations, the two workstations in the foreground are used for routine operations, such as public, aviation, and fire weather forecasts. The two in the center right portion of the screen will be used to issue warnings. Free communication between the forecasters allows information to be shared easily. Toward the upper right is our communication and social media workstations. They will collaborate between the amateur radio area in the far upper right, and the public service desk top center, and the severe weather workstations to make sure everybody receives up-to-date information. Finally, the public service desk takes phone calls, monitors river levels, compiles climate data, sends severe weather reports, and launches a weather balloon twice per day. This is a standard workstation. We have 8 of them in our operations area. 2 screens are dedicated to a PC, 2 for displaying graphics, and 1 for typing products and collaborating with other weather offices. D2D is a software program on our graphics workstations that allows us to view virtually limitless amounts of weather information and model output. For example, the large frame is an infrared satellite image of thunderstorm development in the southern plains in Mississippi Valley. There are 4 smaller frames on the left that can be swapped into the larger frame. Also notice the several tabs at the top, which can display even more information. This is just one example of how a forecaster may set up their workstation to monitor the weather. Each situation may require a different layout and things to monitor. For example, a severe weather warning forecaster will not need to look at surface temperature forecasts several days down the road. We determine whether a storm needs a warning by investigating the storm on radar, considering the environment the storm has formed in, such as is it capable of producing severe weather, and finally reports on the ground from severe weather spotters, amateur radio operators, first responders, emergency management, media, and the public. Generally, 2 of those 3 criteria results in a warning being issued. To issue a warning, the forecaster launches a program called WarnGen. A small window pops up while a centroid appears on the map. The type of warning is selected, in this case a severe thunderstorm warning. The forecaster moves the centroid to the storm. For fun, let's say it's over our office in eastern Carver County. The last storm motion calculated is used, and in this case, a first guess warning polygon to the northeast is immediately displayed. After stepping back a few frames on radar and placing the centroid back on the storm over southwestern Hennepin County, the updated storm motion vector is displayed. By hitting the track button, a new polygon is generated based on the updated storm motion vector to the south. Several manual edits are made to the polygon by dragging the corner vertices around. In this example, the box is tapered around the storm and then fanned out toward the southern end to account for possible changes in the storm motion. Also, the polygon is broken off at the LeSueur-Rice County border since the storm isn't expected to reach those locations during the valid warning time. Depending on the evolution of the storm, another warning may be necessary for those areas in 15 to 20 minutes. The duration of this warning is extended until we are sure the storm will be completely out of the box when it expires. This prevents us from having to issue another warning in areas already being warned. Once the polygon is ready, the forecaster selects the hazards associated with the storm. In this case, 60-mile-per-hour winds and half-dollar size hail are selected. Scrolling down a bit more, we have the option of including tornado possible wording in the warning if we note some rotation but aren't confident in issuing a tornado warning. Also, the pathcast is selected, which will mention when cities are expected to be impacted. One call to action is selected. These explain what people in the warning should do. Create text is clicked. The warning pops up on the text workstation where the forecaster can look it over and hit send. After a confirmation box pops up and the forecaster hits go ahead, the dissemination process begins. Weather radio and the emergency alert system are activated, and TV stations may scroll the warning on the bottom of the screen. It only takes about 45 seconds from the time a meteorologist decides to issue a warning to when people are being notified. If another office gets knocked off the grid, or their staff needs to take shelter, we have the ability to issue warnings for Duluth, Sioux Falls, or La Crosse by selecting the office under the backup drop-down box. There are many ways for the public to receive warnings, and it is recommended to use several of these to make sure you get it. Tornado and flash flood warnings are sent directly to your cell phone free of charge through the Wireless Emergency Alerts program. You may also choose to have a weather radio, watch a local TV station, listen to commercial radio, use an app or a private alerting service. Maybe you have a trusted friend who likes to forward information to you. Outdoor sirens are meant for outdoor use only and should not be used as a way to receive warnings indoors. But if you are out jogging and playing a baseball game, sirens may be the first indication severe weather is approaching. So when you hear a siren, you should quickly seek additional information. After a warning is issued, we ensure public safety personnel have received it through their notification systems. We confirm with Minnesota warning points on 800 MHz and call Wisconsin warning points on the National Warning System, or NWS. Each state, county, and municipality may have their preferred methods to receive alerts. One way we communicate with our partners in the media, emergency management, and amateur radio operators is through NWS chat. This is a real useful tool to pass along ideas and information quickly during active weather. There are many ways you can relay your report to us. You can call us on the phone, interact with us on social media, send an email, or fill out a severe weather report from our website, weather.gov/TwinCities. We encourage people to become trained weather spotters. Spotters provide very helpful information to warning forecasters and provide us with detail we can't obtain from radar alone. We offer numerous training classes each spring for those interested in becoming a spotter. Here is our amateur radio desk and the antenna they broadcast with. Volunteers come in during severe weather events and seek out information to help our forecasters make warning decisions. They too are a valuable piece of the warning program. The National Weather Service is striving to make the United States a weather-ready nation. The Weather Ready Nation Ambassador Initiative is NOAA's effort to formally recognize partners who are improving the nation's readiness, responsiveness, and overall resilience against extreme weather, water, and climate events. Any organization across all levels of government, businesses large and small, nonprofit and non-governmental organizations, and academia can become Weather Ready Nation ambassadors. Upon signing up, you'll even get a raindrop displayed on our wall. Being part of a weather-ready nation is about preparing for your community's increasing vulnerability to extreme weather and water events. Americans live in the most severe weather-prone country on Earth. You can make sure your community is storm-ready. Some 98% of all presidentially declared disasters are weather-related, leading to around 500 deaths per year and nearly $15 billion in damage. The Storm Ready program helps arm America's communities with the communication and safety skills needed to save lives and property before, during, and after the event. For more information about the program, visit weather.gov/stormready. This is our graphical forecast editor. It is the program we use to maintain our forecast database. We can load in any one of dozens of models, blend models together, and collaborate with our surrounding offices rather easily. Each grid, or small box with each forecast element to the left of the main image, represents the forecast for that element for the given time. Time increases to the right. Our forecast is valid for the next 7 days, so we have to quality control thousands of grids. Luckily, we have tools to help us. Our max and min temperature grids span the entire day, whereas the hourly temperature grids last only 1 hour. We use tools to help us calculate hourly temperature from the max and min temperature forecasts. Here are dew points. The dew point is the temperature at which air must be cooled for humidity to be 100%. From hourly temperature and dew points, we can calculate the humidity. We've got wind speed and direction, wind gusts. From temperature, dew point, and wind, we can calculate apparent temperature, which is the heat index during the summer and wind chill in the winter. The amount of sky covered with clouds. Weather types such as rain, snow, sleet, thunderstorms, fog, blowing dust, etc. Probability of precipitation. Precipitation amount. And finally, snow amount. All of those elements we create in GFE are published and updated on our website and the National Digital Forecast Database. Here are some of the products available on our website. Each of these will be discussed a bit later. This is the program local weather offices use to construct and monitor observations at our TAF or Terminal Aerodrome Forecast locations. TAFs are issued 4 times a day, or every 6 hours, covering the next 24 hours. Since Minneapolis-St. Paul is a major airport, we issue an intermediate amendment 3 hours after each issuance of the routine TAF, and the forecast covers the next 30 hours. We are able to quickly see if observations of visibility, wind, weather type, and ceiling differ from our forecast when those elements become highlighted in the table. Appropriate amendments can be made to the forecast when necessary. Here is what a standard TAF looks like. Each line indicates the predominant weather expected for the time indicated in Zulu time until the time indicated in the next line. The goal is to not forecast every change in the weather, but to convey trends while taking into account important thresholds unique at each airport. Each line begins with the date and time. For example, the second line is the 27th from 0230 UTC onward. That is followed by wind speed and direction, visibility, any weather such as light snow, and finally sky cover and ceiling in hundreds of feet. The National Weather Service is moving toward digital aviation services, which will allow all locations across the country to construct an unofficial TAF based on a gridded forecast. Similar to the other forecast elements discussed before, forecasters can modify these grids by blending models or by hand. Here is the ceiling grid and the visibility grid. This is what our local office website looks like. Let's point out some particularly useful features of it. Under Forecast, you can select the Activity Planner. The Activity Planner allows you to enter desirable values for elements you are interested in. Let's say we're planning to go fishing and we want temperatures between 72 and 78 with winds less than 8 miles per hour. If you click on the map or enter your latitude-longitude, the page will display the times your criteria are expected to be met. Here are the results of our search for the next week. Where the elements overlap is where all the desired criteria are being met. Now let's look at the products that feature hourly precision by clicking on Hourly Forecast. You'll have 3 options: the standard point-and-click 7-day text forecast, the hourly weather graph, and the digital or tabular forecast. If you click on the Rivers and Lakes link, A map of our region will appear, and dots indicating the current flood stage will be displayed for each observation point. If you click on one, a hydrograph will display. The blue line is the observed stage from the past 6 days. The purple line is the forecast stage for the next 5 days as produced by the River Forecast Center. Back to our home page. Now under the Local Programs menu, select Enhanced Hazardous Weather Outlook. This page highlights the degree of risk associated with a number of weather hazards. We clicked on Sunday's lightning threat box, which highlights an area of yellow or limited lightning risk across southwestern Minnesota, which indicates thunderstorms are expected to be isolated in coverage. The definitions of the risk levels will be shown below the map for the selected element. Back to our home page a final time. If we scroll down, we'll see the weather story. If you click on it, the image will enlarge and a narrative will be shown below the graphic. The weather story is meant to highlight the most important feature during the next week. Thank you for taking a virtual tour of our office. If you have any questions, please contact us on social media at NWS Twin Cities or give us a call at 952-361-6670. Thank you.